Alright, so this is slope notes part 2. Slope-intercept form is how you write an equation for a line. It has 4 parts. You've got your m, which is your slope, your b, which is your y-intercept. For those of you who don't remember, y-intercept is where it hits the y-axis. Okay? And then you've got your x. Your x is your input value, and your y is your output. So that is slope-intercept form. So the letter we use for slope is a lowercase m, because it comes from the French word monter, which means to climb or to rise. So you pick out the m plus b from each equation right here. So right here, this is the number next to the x. I'm going to write my slope-intercept form underneath it just so it's easy for me to see. 4/3 is next to the x, so that's my slope. And my y-intercept is -12. What this tells me is if I wanted to graph this equation, I would start at 0, -12, and then I would go up 4, right 3, and that's how I would graph that line. Same thing here, I've got y equals mx plus b. In my m spot, I've got -3. My b spot is -2, so if I were to graph this, I would start at 0, -2, and then I would actually go down 3, right 1. For this guy, 15 is in my slope spot, 7 is in my y-intercept spot, so I would start at 0, 7, and then I would go up 15, right 1. Okay, and for this last one, this one's a little tricky, and the reason it's a little tricky is because you don't actually see a number in front of your x. But what I know is 1 times anything is itself. So what's actually here, even though we can't see it, is a 1. So the slope is -1. Now because I do not see my y-intercept, it's 0. So this tells me I would start at the origin, or 0, 0. Then I would go down 1, right 1. Okay, go ahead and pause the video and do these 4 problems. When you're ready, resume it, and I'm going to walk through them. Okay, here my slope is -3/2. My y-intercept's 8. Here my slope is 4. My y-intercept's 1. Here my slope is 1. My y-intercept's -7. And that again is because even though I don't see a number here, the 1 is implied. And then here my slope is 3 and my y-intercept is -2. Alright, so now we're going to find slope from a table. So when given a table, determine the slope by putting the change in y over the change in x. So what that means is we're always going to look at, so if we have x and y, you're always going to look at this side first. That gives you your numerator. And then this side is going to be your second, and it's going to give you your denominator. And we're just going back to that original formula that we had, where we had y2 minus y1, that's a y, over x2 minus x1. So change in y over change in x. Same thing we did last class. Alright, so looking at this guy, we're going to do 4 and -2. So that's going to look like 4 minus -2. Because remember, you're changing y. And then on bottom, you're going to have your change in x. So that's -3 minus 0. 4 minus -2 gives you 6. -3 minus 0 is -3. And I know that I can take a 3 out of the top and bottom, which reduces down to 2 over 1. So my rise here is -2. So it's actually not a rise. Our run is 1. Our slope is -2 over 1. So what that looks like is negative 2x. Now we can actually determine our b here. And the reason we can determine our b is because we see the 0, negative 2. Alright, so we know that our y-intercept always has a 0. So that's actually our b. So our full equation is going to be y equals negative 2x minus 2. So we're going to check this by graphing. So I'm going to graph the point negative 3, 4. So 1, 2, 3, 1, 2, 3, 4. Then I'm going to do 0, negative 2. Then I'm going to do 3, 1, 2, 3, negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. Alright, and then we're going to connect our points. Okay, what I see on this graph, now this is really hard to see because the graph paper is not very good. So if you want to do this on a separate sheet of graphing paper, you should, because this is very, very difficult to see. So if I check the slope here, I would get negative 2 over 1. Again, it's very hard to see that because this graph paper really sucks. Okay. And then you see that your y coordinate is right there. Alright, our next one, we have our x's right here and our y's here. So I'm going to do 8 minus 3 on top, 7 minus 3 on bottom. So that's going to give me 8 minus 3 is 5. 7 minus 3 is 4. So my slope is 5 over 4, meaning my rise is 5, my run is 4. Now, we don't know my y-intercept here because I don't have a 0 as an x. So we're going to have to graph that to find our y-intercept. So as I said on the last problem, our graph paper here is really bad. So I'm going to do it on a separate sheet of graph paper. Alright, so I've got my y-axis and my x-axis. My first coordinate point is 3, 3. So I'm going to go 1, 2, 3, 1, 2, 3, put a point. My next coordinate point is 7, 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 1. Oh man, I can't do 8 because I didn't plan well enough. Alright, guess we got to start over. You know that happens sometimes. Try again. So we got to make sure we give ourselves plenty of space. Alright, so 1, 2, 3, 1, 2, 3. And we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So that's my next coordinate point. I cannot do 11, 13, but I have enough on here. Make it work. Then we want to make sure we get a straight edge. 1, 2, 3, 4, 5, 1, 2, 3, 4. So you can see your slope right there. So get yourself a straight edge. Alright. So my straight edge, when I draw this all the way out, I can see my y-intercept right here. So my equation would be y equals, and I have my slope 5/4. So 5 over 4x minus 1. It looks like that's what my y-intercept is. So I got my y-intercept from graphing. Okay. Alright, my next one, I'm going to do 22 minus 2, 11 minus 1. That's going to give me 20 over 10, which reduces down. 20 divided by 10 is 2. So my slope is 2, which means its rise is 2, run is 1. So my equation is y equals 2x, and we don't know our b yet. We're going to have to graph to find this. Okay. Alright, so we've got y equals 2x plus b. So we draw our little graph here. And we know we have a point of 1, 2. We know our slope is 2 over 1. So what I'm going to do, because these points are so huge, I'm actually just going to go for my slope up here. Because I have one coordinate point and I have my slope. So I'm going to start at this coordinate point. I'm going to go 2, 1, up 2, right 1, up 2, right 1. Okay, and then I'm going to take my straight edge. Line it up, connect them. And now that I've graphed it, I can see that my coordinate point is 0, 0. That's my y-intercept. So my formula is going to be y equals 2x plus 0, or y equals 2x. Okay, so that's my final formula. So again, I graphed that to find my y-intercept. Okay, so my final equation is y equals 2x plus 0. Alright, go ahead and practice these. So pause it, practice it, and then I will show you what the answers are. Okay, so 6 over 2 reduces to 3. So our slope is 3, rise 3, run 1. So y equals 3x plus, and we actually do see our y-intercept because you see 0, 8, and we know our y-intercept is when x is 0. And then we have this one, so 22 minus 8 over 9 minus 2. 22 minus 8 is 14. 9 minus 2 is 7. 7 divided by 14 is 2. Again, we do not see our y-intercept here, so you can graph it. I'm actually going to show you the second thing, so you can graph define or plug in 0 for x. And the reason that works is because your y-intercept is 0, b. So you can also do y equals 2 times 0. Oh, wait, no, that's wrong. Don't do that. Mrs. Hicks messed up. It happens. Or you can plug in a coordinate point. Sorry. So I'm going to plug in 2, 8. So you can graph it like I taught you, or you can do the plug in a coordinate point. So what that looks like is 8 equals 2 times 2 plus b. So you plug in the 2 for x, you plug in the 8 for y. And then we solve that just like we would a normal equation. So this tells you your y-intercept is 4. So your final equation is 2x plus 4. So you can always graph define it, or you can plug in a coordinate point and it'll work every time.